Good morning. We're going to talk about Lesson 18 this morning. This is Saxon, Course 2, Lesson 18, and we're going to talk about recognizing polygons. And some ways that we can recognize polygons is whether they are similar or congruent. So that's kind of what we're going to focus on today, and that's pretty much what we're going to talk about. First, a vocabulary word. Polygon. When three or more line segments are connected to form a closed shape. Now two wouldn't work because two would just create a line or an inequality sign or something like that. We've got to have three lines connected together. So for example, we have this shape here. It is not closed. It has 1, 2, 3, actually 4 lines, but it's not closed, so therefore it's not a polygon. This shape here, 1, 2, 3, 4, 5 sides, it is closed. Every corner meets at a vertex, and so therefore it is considered a polygon. There are types of polygons, and they're classified by the number of sides. You'll need to write these in your notes. And I'm just going to uncover them so you can kind of start writing as we talk. You're aware of most of these, except some you might not know the names of. A three-sided polygon is a triangle. Four-sided is a quadrilateral. Five-sided is a pentagon. Six is a hexagon. 7 sides, heptagon. 8 sides, octagon. 9 sides, nonagon. 10 sides, decagon. 11 sides, undecagon. And 12 sides is dodecagon. Kind of hard to pronounce sometimes, but that is as far as we'll go as far as naming them. There are more names for larger items with bigger sides, but that's where we'll stop today. Okay, talking about a little more vocabulary when it comes to polygons. We have vertexes. The vertex is the place where two sides meet. These right here labeled with the dots, those are all places where sides meet, and those are all vertexes. So vertex is the point where two sides of a polygon meet. In this case, we have regular polygons, and regular polygons, all the sides are exactly the same length, and the measure of every angle is the same. A good example of a normal regular polygon that we see all the time would be a square, because all 4 sides are the same length, and all the angles are 90 degrees. Octagons that are like stop signs, things like that, those all have the same length sides, and all the angles inside would be exactly the same measure. Irregular polygons, the sides are different lengths, and the inside angles are also different. Okay, I'm going to talk a little bit about similar figures. Similar figures, I'm going to zoom in just a little bit. They have the same shape, but they aren't necessarily the same size. So this triangle and this triangle have the same shape. Its inside angles will all measure exactly the same, believe it or not. This figure is drawn really, really small here, replicated very large here, same shape. If you can think about like a copy machine where you can enlarge something or you can reduce it, that's basically what we're talking about when we're talking about similar shapes. Same thing as if you take a piece of graphic or an artwork off of the internet and you take it and you get it into your whatever your document is you're working on, and maybe it's really, really big and you have to shrink it down, take the corners and shrink it down. It's the same thing, it's just smaller or larger than it was before. So that's the whole idea of similar figures. They are the same shape exactly, just a different size. Okay, we're going to talk a little bit about congruent figures. Same shape and size, I think I already said that. Okay, and if you had a pair of congruent figures, this might be one way they would be labeled. A and B are congruent. Notice the line here and the line here, line here and line here. That means that this side, this side, this side, this side are all the same size, exactly the same size. And this line, this line, this line, exactly the same size. So they are congruent. They have the exact same size, same angles, same everything. Their corresponding parts are the same. To determine whether a figure is congruent or similar, we compare the corresponding sides, parts, and angles. For example, we have two triangles here. Okay, we're hoping that they're similar. We would have to compare their angles, but at this point we see that this line and this line, okay, shows congruence. These three lines, these two, they're corresponding congruent. Okay, they have the same, they don't necessarily have the same length, but they are corresponding sides, and you would find that this angle and this angle would have the same measure. This angle and this angle would have the same measure, and this angle here and this angle here would have the same measure. It is if I took this triangle and I shrank it. Okay, so corresponding means that this and this correspond. These sides may not be the same length, but they are proportionally the same. So this one might be 2 times longer than this one. That would also mean that these two would be related by this would be 2 times longer than this one, and this would be 2 times longer than this one, and their angles would all be exactly the same measure. It's funny how an angle can be the same measure in a little figure that it is in a big figure, but it is true, and when you have corresponding figures, that is the case. Alrighty folks, that was it. That was a short one this morning. I hope you have a great day, and we will see you. Goodbye.